lastly, we're going to look at a pipeline that can help us enrich some data and do some basic feature engineering for predictive modeling. So in this pipeline, my analysts have decided that they'd really like to analyze how a station's proximity to a Starbucks location affects its peak hours. So in order to do that, I'm going to bring in information about my station dimension. And in this case, I'm going to bring in some census data as well that I've gotten from a data share. And I'm also going to bring in Starbucks location information that's also from the Snowflake data marketplace. And what I'm going to do is use all that location information for the Starbucks in New York City. And I'm going to figure out the hours that each store is open based on some of the data provided there. And you can see that the JSON parser is allowing me to create a new column for each one of those fields. And I'm going to join those two data sets together and then calculate the distance between each station and Starbucks location. So from there, what I'm able to do is use our deduplication processor, which actually is a Python Panda style deduplication. So what that means is you're able to deduplicate based on a set of keys in that data set, but when it deduplicates the records, it keeps the entire record. So you don't lose any detail due to having to aggregate or anything like that. So once we've deduplicated and found each station's closest Starbucks, what I really would like to do is collapse the data. And so unfortunately, we don't have an on-pivot processor. So what am I going to do? So for this very reason, we have a SQL query processor. And so what that means is that anything you can do in SQL, you can do in this processor. So if we don't have a stage for it, or it's something extremely complicated and an edge case, you can put that SQL right in here, and it will just treat the input stream as the source table, and the results will be fed into the output stream. So in this case, it's really simple, but this does support extremely complicated logic. And then finally, I'm able to join that into the trips data where I've already enriched with some of the weather data. And finally, I can do a little bit of feature encoding. So I'm going to create some binary features that to describe things like if a ride happened when its closest Starbucks was open, is it within certain perimeters of distance to a Starbucks? Is it less than 1/10 of a mile, less than 1/4 of a mile, less than 1/2 a mile? And then also some information about the weather, since that will also have quite an impact on whether or not people are riding bicycles. So hopefully you can see here that, again, with this pipeline, I'm able to bring in a bunch of different data sources, right, from some external sources. And I'm really able to kind of manipulate the data to get it into the shape that my data science team will need in order to start to do some model fitting and see if they can find a relationship between station location and a Starbucks location. So that was another example of some of the pre-programmed logic that StreamSets Transformer for Snowflake supports. And I hope today's demonstration has succeeded in showing you the value of the dynamic and complex pipelines that Transformer for Snowflake allows you to create and then execute natively in Snowflake.